All right, hello everybody. We're gonna do something a little bit different today. Instead of going online and finding a parallel circuit, what we're gonna do is use the one that I just created right now. Okay, so in series circuits, there's only one path for the current to follow, so that's why the current's the same. In a parallel circuit, it's not quite the same because there are multiple avenues for the current to cross. Like you see right here, it can go down here, or down here. That's why the current is different in a parallel circuit in most circumstances. However, we will solve for the same things that we do in a series circuit. It's just going to be in a little different way. So, starting out, we are given the resistance totals, or the resistance for each individual resistor, and we're given the voltage total. But that's about it. The rest we gotta solve ourselves. So let's start by finding the resistance total. We can do that by taking the inverse sum of the inverse of each individual resistor. So let's say you see 10k ohms for R1. It's going to be 1 over 10k ohms. And it's going to be the same for 2k ohms. And it's going to be the same for our 1k ohm. And then we take the inverse sum of that. So equals, okay, let's just have it be equal to RT over 1. Okay. Putting that in our calculator. If you have a Texas Instruments calculator, you will be hitting the 1 over X button for each individual value. So it would look a little like this. 10K, so it'll be 10 EE3, 1 over X plus 2K, 1 over X plus 1K, 1 over X equals, and you take that sum and you put the inverse of that, and sum of this is going to be 625 ohms. Let's just double check that. 10K. Yep, 625 ohms for resistance total. Okay. For a parallel circuit, the voltage is the same. So in series, the current's the same, but in parallel, the voltage is the same. So that's why we can just leave it 9 volts, 9 volts, and 9 volts. Eventually, we're going to be working with series parallel, which we would have to use both of the concepts, but that would be a different day. So to find the current, what we do is we take our resistance and let's just bring up the triangle. V over I times R. We're looking for current, so let's block it up. We take the voltage and divide it by the resistance. So our voltage is 9 volts, and we're going to be dividing it by our individual resistors. So let's just do the individuals first, and then we can guess what the total is going to be. So we have 10K, or we have 9 volts divided by 10K ohms. 9 divided by 10K is equal to 900 microamps. Let's do 9 volts divided by 2K. That's equal to 4.5 milliamps. Now let's do it from 1K. That's equal to 9 milliamps. So we have our individual current values. 900 microamps, or 0.9 milliamps, 4.5 milliamps, and 9 milliamps. And it's good just to keep everything in the same base value. However, this is not really proper. You're supposed to remove the decimal place when you're doing this. However, just keeping it all the same is going to become easier to add this up to get our IIT. So to do that, we just add up our individual currents, and it'll give us the current sum. So We have our 0.9 milliamps plus the 4.5 milliamps plus the 9 milliamps, and that's going to be equal to 14.4 milliamps. That's my predicted value. Let's see if I'm right. And we can do that by taking our resistance total, which is 625. And we're going to be multiplying that by... No, we're not multiplying. We're dividing 9 volts by 625. So let's put that in our calculator. 9 divided by 625 is going to be equal to 14.4 milliamps. So we are right with our prediction. Moving on to power, it's going to be the same idea. We're just going to multiply the voltage by the current to get the power. So let's just do that on our calculators. We have 9 volts all the way. 9 volts. And for current, we have 0.9. Actually, let's do it like total first. 14.4 milliamps, 0.9 milliamps, 4.5, and 9. Now we're finding power. So 9 times 14.4 milliamps equals 129.6 milliwatts. So this is going to be my predicted total for all the individual currents added up. We're going to multiply 9 by 0.9 milliamps, and that's going to be 8.1 milliwatts. 9 times 4.5 milliamps equals 40.5 milliwatts, and 9 times 9 milliamps is equal to 81 milliwatts. So adding these up, we have 8.1 milliamps plus 40.5 milliwatts plus 81 milliwatts, and that's going to be equal to 129.6. So yeah, we just add this up. 129.6 milliwatts. And that's gonna, let me just write it down here, and that's gonna be our answer. 129 milliwatts. And I don't care if you have the work anywhere, you always want to at least have it in your chart, because you can't be wrong unless you, miscalculate. But you can't be wrong if you have it on the chart. So it's going to be 8.1 milliwatts, 40.5 milliwatts, and 81 milliwatts. And before we submit, what we always do is make sure our base units are correct. You see this right here? 0.9 milliamps. Let's just fix that to be 900 microamps, and we will be done. This is correct. Thank you, everyone. Have a good day.